if I am going to use slope-intercept form, that form is y equals mx plus b. Is that the same as that?
No.
What is different, Jashin?
First of all, it's flipped the other way around.
It's flipped the other way around, and
There's 3y instead of...
there's 3y instead of only 1y. So what could I do to this blue to make it look like this blue? You got to get the y alone. So we're going to do algebra. The y is already positive, so we're not going to move him. Because if we move him, he would be negative. We don't want a negative y, we want a positive y, don't we? So we're going to move everything else. Now, in grade 9 and 8 and 7, when your previous Mr. and Mrs. Bad Crumbles were teaching you math, they always said to write it out. And I always say to write it out. But in the interest of time, I would like you guys to by now you should have started noticing a pattern. If I subtract 2x from this side, I must also subtract 2x from this side. Meaning, I will have 0 here, 0x's here, and negative 2x's over here, yes? So by now I am hoping you notice the pattern that when I take something from this side and I need to move it over here, all I do is change the sign. Right? So I'm going to have 3y minus 4 equals negative 2x, yes? Is y by itself yet? No. What else needs to move? The 4. If I move the 4 over the equals sign, what happens to them? So now I have 3y equals negative 2x plus 4. Now what? Is y alone? It's got a 3. So I'm going to divide by 3. Where else? Everywhere else. And I'm going to be left with y equals negative 2/3 x plus 4/3. Now, what is it about this that makes it a pain in the holly to graph? The fraction. Which fraction? The 2/3 or the 4/3 makes it difficult to graph? The 4/3, because that's the y-intercept, isn't it? If it was 4, I would just go up 4. But it's not 4. It's 4/3. So what should I do to my graph to make this easy to graph? Change it into what? What is each square worth now, Brianna? Each square, single square, should be worth what? 1/3. Then I can go 1, 2, 3, and there is 1. So that is 1, 2, 3/3, and I need a 4th third. Does everybody understand? Excellent. Now, does that scale work for the x's? Yeah. Yeah, because it'll fit on here, won't it? Right? So, now, what do I do if I'm keeping the same scale? I go 1, 2, 3, and I put a 1 right there. Now, I have my point. I have the same scale on both. So how do I put my second point on the graph? Yeah, how do I use the slope to get a second point on the graph?
We go to the left 2 and up 3.
Left 2 and up 3. Look again.
Down 2.
Down 2.
Right 3.
Right 3. 1, 2, 3. Right? Because it's rise over run. Negative 2, down 2, and a run of positive 3. Now, should I have 2 spots or should I have 3 points to make sure? 3. So where else can I go from here? Up 2, 1, 2, and left 3. And because I use the same scale on both, all I need to do is count. Does everybody understand? If the scales were different, could I count squares? No. If the scales are different, I have to count values. Does everybody understand the difference? That sounds like a not really, Mr. Myers. I'm just saying sure because you want me to say sure. Do you understand the difference? I want to make sure you understand the difference. I'm going to draw a line on this graph right here. 1, 1. What is that line's slope? And I'm going to zoom in significantly to make it easier for you to see. What is that line's slope? The scales are the same, so tell me that line's slope. How would you do it? You'd look at the line.
And then you see where the line is set at the middle of the block.
You would go to one point and do what? Count up how far? 1, 2, 3. And then, so that's plus 3. And then this way, how far? 1, 2, 3, 4, 5, 6. So that would be 3 over 6, which would be a slope of 1/2. Does everyone understand that? All right, now tell me what that same line slope is now. You can't use counting, so you have to use values, yes? Each square going up and down is worth how much? 1. 1, 2, 3. So what's my rise? 3. Each run is how much? So what's my run? 30. So what's my slope? 1/10, because it's 3 over 30. Does everybody understand the difference here? Same appearance, totally different slopes, because we changed the values. Everybody good? Going once, twice, thrice. All right. Excellent. We're gigantic. All right, next. In this one, I specifically said I wanted to use X and Y intercepts. What is every single X-intercept in the universe? X, 0. What is? Huh? Good. What is every single Y-intercept in the universe? 0 Y. But my computer is still frozen, so I'm still waiting. Yes. Oh, this is a hardcore freezing. It's still frozen. Wow.
Wow, I'm getting a reminder from 2038.
Every single X-intercept, X, comma, 0. Every single Y-intercept, 0, comma, Y. That's an X. That's a Y. What letter is that? What letter is that? So what can I do with that letter X? No. I substitute it for X. And I get 5X minus what? 10, not Y. 0 plus 15 equals 0. 5X plus 15 equals 0. 5X equals what? Negative 15. And what does X equal? Negative 3. Everybody cool? Great. Now, we do the same thing with Y. Now, you guys should be smart kids here. You notice that when we were looking for the X-intercept, the Y term dropped out, correct? So now we're looking for the y-intercept. So what's going to happen to the x term? The x one drops out, and I'm going to get negative 10y plus 15 equals 0. Negative 10y equals negative 15, and y equals 15 divided by 10. Positive 1.5. Now, what do you notice about that and that? One of them makes it a pain. Which one?
1.5.
1.5. So which scale do I have to change to make my graph easy to draw? I got to change the y or the x? The y. So I'm going to go up 1, 2, and I'm going to say that's 1. And I'm going to zoom in to make it easier for you. So since I've put 2 squares is worth 1, I need to go to 1.5. So how many squares up do I go? 1, 2, 3. Now, will that scale work on the x-axis? I need to get to 3, which means I need how many squares? 6. Does that fit?
Yes.
Yes, so I can keep the same scale. How do you show me that you kept the same scale? You go over there and you put a 1. And I go to negative 1, negative 2, negative 3. And I connect the dots. Now, how many points does Mr. Myers say you should have to make a proper line? 3. So I need to go up 1, 2, 3, and over 6. So where's my next point? 1, 2, 3, and over 6. Gouda? Great. Those questions would both be worth this guy would be worth 1 for the algebra, 1 for the graph to get 2. This guy would be worth 1 for each intercept and 1 for the graph to be worth 3. And here's why. This is good for you guys to know because I'm about to give you a test on this. If you two don't care, then leave. Okay? I don't want to interrupt your conversation because that's so rude of me. Because it's obviously so much more important to you than Math 10. So by all means, carry it on, but carry it on elsewhere. Okay? The reason I am doing this is because if you figure out the x and the y intercepts, but you figure them out wrong, you're bad at algebra, but you put them in the right spot over here, you recognize that the y-intercept needs to be on the y and the x-intercept needs to be on the x. Those are two separate things, yes? One is a skill you learned in grade 8, right? Let's be honest, algebra, probably before grade 8. And the other one is something that we're talking about for the first time now. That's why I give extra marks there, okay? Because almost all of you would find the x-intercept no problem, but a lot of you were a little thrown by the y. I heard like 4 different answers for that, even though it's the exact same math, right? Okay, 5 more minutes. Do 3 and 4. Go. All right. How do I find the slope between 2 points? Right. You think that, oh, Mr. Myers told me that it's how much the y's rise, over how much the x's change, run. Yeah. Now, yes, Brianna?
Hey, I didn't y1 minus y2. Does that matter?
No. As long as you do the change in y's. You've actually led me to my next question. Does it matter which is y1 and y2? Does it matter which you write first, y1 or y2? Does it matter if you choose y1 and you make his partner x2? That will mess you up. So no matter what, as long as you choose these and keep them the same pairs, you can do this. So if I make this guy y2, what does that make this guy? y1. And if that makes, what does that make this guy? x1. And what does that make this guy? x2. Now, no matter what order I do this in, as long as I have my y's in the numerator and my x in the denominator, it's going to work. So I'm going to go 2 and 1. y2 is 3 minus, what's y1? 4 over, what's x2? Negative 10 minus 2. 3 minus 4 is what? Negative 1. Negative 10 minus 2 is what? Negative 12. What's my slope? 1/12. Because two negatives make a positive. Now, if we had done what Brianna just said she did, well, Mr. Myers, I went y1 minus y2. So that would have been 4 minus 3 over 2 minus 10, right? 4 minus 3 is negative 1. 2, or is positive 1. 2 minus 10 is positive 12. Still 1/12. She got the same answer. Gouda? Great! Find the slope of the line that is parallel to this guy. I got to find the slope of this guy, don't I? How do I find slope? By the way, this would have been out of 2. How do I find slope? Y equals mx plus b. As long as y is by itself, I have slope, don't I? So what do I do with 5x minus 3y equals 12 to get slope? As long as I get y by itself, I'm going to know slope, aren't I? So y needs to be by itself and positive. Right now, y is negative. So what would I do to make him positive? What could I do to this guy? What?
Put him over on the other side.
If I move him over here, what happens to his sign? Becomes positive. So then I would have 5x equals 12 plus 3y, right? Is y by itself yet? What do I got to do to that 12? I got to move him over. So now I have 5x minus 12 equals 3y. Now what? Divide everything by 3, and I get 5 over 3x minus 4 equals y. Is that slope-intercept form? Yes. Where does the slope live there?
5 over 3.
Right there. So I need a line that has a parallel slope to that. If it's parallel, what are the slope? The exact same. So, is 5/3 cool? Is 10/6 cool? Is negative 15 over negative 9 cool? Yes. Is 1.4 cool?
No.
Why?
Because 9 divided by 3
Is what?
is 1.6666666.
Good. Good. So that would not be okay. Nice. All right. Excellent. Another 2 minutes. Oh. Let's say 5 minutes. Yeah, 5 minutes to do 2 because the last one takes a while. Go. What? I'll be right over. So that would have been worth 2 as well. You guys go on to do 5 and 6.
I have a question quickly. Is that okay?
What?
I have a quick question.
Yep.
I don't have to do past here.
Well, then I just explained it, didn't
I
I?
know. I was writing my stuff down.
Okay, so once you have that, you know the slope. all parallel lines have the same slope. So once you have
One sec, I have one more room that I hope I win. Oh shoot, I am struck. Oh.
all right.
Alright, I'm almost done. Use the gift card that they bought you last year to buy their pieces. Alright.
It's a sweet move.
You should buy them a gift card with that gift card.
Oh, what fun! Free gifting!
All right, here we go. So it's the exact same question, almost, isn't it? First step, same thing. Find the slope with which you are working. 2y negative 7x plus 10. Divide everything by 2. Negative 7 halves plus x plus 5. But I do not want the parallel line. Now I want the perpendicular line, which means what?
You gotta change the signs and reciprocate.
Change the signs and reciprocate the fraction. So I need a slope that equals 2/7.
Yo, I got it. Didn't you get it? Oh, no.
Everybody good?
I said 4.
I got 2. I'm so happy.
Is this for marks?
It might be. What? Were you able to get to here, Mr. Anderson?
No.
You got y by itself by moving the 7 and moving the 10. And then you divided everything by 2. Okay, so there's the slope. But I don't want that slope. I want a perpendicular slope. Which means I flip any fractions and I change the sign.
Okay. I get it.
Just like we did yesterday, Friday. You weren't here Friday, but there's a video. All right. Now, this question, number 6, I said to try number 6. Number 6 is very, very easy if you graph it. Because if you graph it, all you need to do is count. But once you graph it once, you will see that you never have to graph it again. Because if you graph it, you have a point at negative 5, 1, 2, 3, 4, 5, and down 2, correct? And your slope is negative 2/3, yes? So all I have to do from there is count either down 2, 1, 2, and right 1, 2, 3 to make a dot, yes?
Wait, is that y over x? Is that 2/3 y over x?
Of course it is. It's rise over run, like every slope.
Oh, yeah.
So I did negative 2 and a run of positive 3, right? So my y's went down by 2. What did my y start at? Negative 2. And then it went down by 2. So what did it become? Negative 4. And my runs went up by 3. My run did. So I started at negative 5 and I went up by 3 to get to negative 2. And now you should recognize that you never need to graph it, do you? Because all you need to do is add or subtract from your coordinates. What would the next one be? What would be 2 lower on the y's? And what would be 3 bigger on the x's? 1. Could I go the other way? What would be 2 bigger on the y's? 0. And what would be 3 smaller on the x's? Negative 8. And then 2 bigger from that? 2. And 3 smaller from that? Negative 11. And now you should be able to see that you can find it without ever graphing it. Of course you're allowed to graph it. You're always allowed to do whatever you need to do. As a matter of fact, Tasha, keeping your graphing skills up will be extremely useful in the next 2 years. Because in the next 2 years, you will need to be able to do both. And a great many people like to forget about the graphing. Gouda? That one out of 2. Now, this one. You have 5 minutes to work. Well, you won't need 5 minutes, but... This one is perfectly doable without ever graphing it. But it cuts your work by 67% if you make a sketch graph. That is a very accurate number. Oh, and I didn't record the key to that. Ah, well. I'll go back to it in a minute. Now,
The answer is not a right triangle.
you have been told 3 ways to graph linear functions. One way you learned in the 9th grade. How did you graph a line in the 9th grade? What did you use? Table of values. In the 9th grade, you learnt table of values. X, Y. Which of those 2 numbers did you choose? The X's. Put it into the equation, got the Y's, graphed it. Right? That's what you did all through grade 9. In grade 10, on the very first day of graphing lines, I taught you how to do it. We use the X
I think I did that last year.
and Y intercepts. And then we taught you a third way. Slope intercept form. Now you guys are smart kids. A line has how many intercepts? 2. How many points does a line have? Infinite. So doesn't it make sense that there would be a way to use slope and one of the other infinite amount of points on a graph instead of restricting ourselves only to the intercepts? And the answer, of course, is yes, there is. There is a 4th way, and it is called point, and I should have changed colors again, point slope form. And point slope form is awesome because it uses slope and any other point. Now, any other point on the graph has what coordinates? X, Y. Everybody cool? Everybody good? This is what point slope form looks like. When I write it, you're all going to go, got it. Because you're going to see everything in this form is something you already understand. Is any of that confusing?
So it's like x2 minus x1, except
We've already got something that uses more than one x and y point. We've already got m, so we're in business, aren't we? Yeah, we are. Now, this point and this point
x2, y2.
are the unknowns. All right? What's this guy? What's M? slope. And then this guy and this guy give us our known point. All right? Now, here's where it gets a little funky. Okay? Y minus y1. X minus x1. If I told you that I had a line, I have a line that goes through 6, 4 with a slope of 1. What does this and this tell you?
X and Y1 are 6 and 4.
That gives me a known point, doesn't it? 6, 4 is a known point, isn't it? And my slope is 1, isn't it? So let's write this out. Y, that's an unknown point, minus, what's the known y value that I have? 4 equals, m, what's my slope? 1, bracket, x minus 6. Everybody agree? Is everybody cool with that? Now stop for a second and look at this. I told you that these 2 points are a known point, right? Which means if I wanted to graph this, I need somewhere to start, don't I? When I have slope-intercept form, I start at the y-intercept, right? These guys give me where to start. But notice, when we write it out, it said minus 4, minus 6. But I am telling you that the point on the graph is 6 and 4. That seems weird, right?
Reciprocal.
Not reciprocal. Reciprocal means their fractions are flipped. They're opposites. And here is why. Everybody understands that that's an X and that is a Y, correct? Everyone understands that, right? And what do you see right there and there? X and a Y. So, if this point is on the line, where can I write 6 in this equation? On the X. So I'd have 1, 6 minus 6, correct? Everyone agree? And what could I put on this side? No. 4 minus 4, yes? What is 4 minus 4? 0. What is 6 minus 6? 0. Does 0 equal 1 times 0? That is why these guys give us the starting point. But you have to be aware that the signs are changed. Is everybody cool? So, let's see if you really get it. Here is an equation. This is in this form, isn't it? Everyone agree? What do I know about this line? What is my starting point? X's go first.
-1.
1.
-2.
-2. Because it's got to be opposite. I'll talk about it in a sec. And what is my slope?
-2 over 3.
-2/3. Remember, it has to be opposite because they have to equal each other, right? If I made this 2, then it would be 2 plus 2, which would be 4. And if I made this 1, it would be 1 minus 1, which would be 0. Would 4 ever equal 0? No, that's why we have to use opposites. Everybody cool? All right. So now what would this guy be? What would this guy's starting point be? -3, +4 with what slope? -1/4. Now we're going to stop there for a second because I want to make sure you can do this. We had y minus, I can't remember what it was now. Y plus 2, 2/3 x minus 1. Y plus 2 equals -2/3 x minus 1, right? And you guys all remembered, okay, it's got to go through 1, -2 with a slope of -2/3. So we graph it by going to 1, -2, and then what? How do I do slope? Down 2 and right 3 and up 2 and left 3 and connect the line. That was not a... Shut up!
He did it. He did it. He did it.
There. And our other one was y minus 4, -1/4 x plus 3. Y minus 4 equals -1/4 x plus 3. And you guys remembered, it can't be +3 or they wouldn't be equal, right? It has to be -3 and +4. 1, 2, 3, 1, 2, 3, 4. And then what do I do from that starting point? Up 1, right 4. Your job is to finish page 198 only. That's 4 questions.
How would I do it without the brackets then?
I went there twice.
I know. I'm.
One sec.
Last time I got